The next piece of functionality we want to implement on our authors resource is sorting. This is a bit different from what we've done with filtering, searching and paging. With filtering, we provide a value for a specific field, singing for main category, for example. With searching, we also provide one value for the search query. And even paging wasn't that hard. But when we sort, well, let's have a look at a few samples. A simple sample would be order by equals age. That's along the lines of what we know. One value for an order by query string key. Important here is to remember that our outer-facing model, in other words, the DTO model, is different from the entity model. As we know by now, that's important, but it also has an impact when we're going to sort. Sorting statements relate to the fields of the resource, in other words, the DTO, and not on whatever lies beneath that layer. It may be different in the backing data store. In our example, the author has an age in the resource representation. In the underlying data store, there is no age. Instead, there's a date of birth. That means that we allow sorting on age and not on date of birth. Let's have a look at another sample. Likewise, we allow ordering by name, but not by first name or last name. And were we to allow ordering by a calculated field, we'll also need some sort of translation to whatever results in the calculated field in the backend store. In other words, sort on resource fields and not on entity or other fields. Let's have a look at another example. Order by equals age DESC, or descending. Well, that's different. We're now also stating how we should order. Still one order by clause, but in our code we have to take into account that one part of the string is about a field and another part is about the order. And we can go beyond that. Sorting typically does not stop after the collection is sorted on one field. You might want to sort on age first, descending, and then on another field, name for example. So that's another thing we have to take into account when implementing this. Let's dive in. In this demo, we're going to implement sorting. We'll allow sorting on all fields, ascending and descending, in order and possibly combined. We're looking at the getAuthors action on the authors controller. This action must be able to accept an order by query string parameter. So let's make sure we can accept that. All we have to do is add it to our authors resource parameters class. Let's also give it a default value, say name. That's a pretty good default sorting order for a bunch of authors. And if the consuming application doesn't like it, it can still pass through another value or even just an empty string. This will also eventually help us get rid of that warning about not using an order by clause we encountered in the previous module. But it immediately also confronts us with an issue. Name is a property on the DTO, but not on the underlying entity model. We need to map this. So let's open the repository. Within the getAuthors_async method, we only want to order when an order by parameter is passed through, so we check the order by property for that. As we remembered, we need to do this before pagination is applied. So let's add it after we filtered and searched. As long as the default value is used, name, we should order on first name first, followed by last name. For that we use the order by and then by methods. Now, this is only valid when the order by clause is name. So let's add another check to that avail. We surround our statement with an if check that checks whether the pass-through order by value is indeed name. Let's give this a try. Let's first get all the authors again. And we get back the first page of authors because paging is applied by default, ordered by name. Back to our code. So this works, but it isn't very reusable. Imagine having to write code like this for 10 properties, which can all be combined in ascending and descending order. That is not very pleasant to do, and code like that is quite error prone. But we do need to map this somehow. So what do? Well, we can write a mapping service that maps a name string to a first name, last name string, i.e. from the property names on the DTO to the property names on the entities. That's part one. Secondly, we will need to apply the sorting. But what we get passed through via the query string are strings. And if we look at this order by clause, and we scroll through the overloads, we don't find any overload that accepts a string. Now we could go ahead and write a huge switch statement for all possible sorting combinations by looking at the inputted string and then mapping that to the actual property. But that won't be pleasant. Luckily, what we run into here isn't a new requirement. In fact, it's a pretty common requirement, and it is for these types of requirements that Microsoft has created the system.link.dynamic library. Let's open the NuGet dialog and search for it. System.link.dynamic has been around since 2008, and it's one of the most popular LINQ extension libraries. And luckily for us, it's been ported to .NET Core. You're looking at that port right now. Through that library, we are able to sort on strings. So let's add this package. So far, so good. So through this package, we should be able to sort on strings. But doing all of that in this repository method won't exactly lead to reusability. And we kind of need some sort of reusability because doing something like this is something we'd like on all resource collections, right? We can separate that out into an extension method on iQueryable. So what we want to end up with is some sort of apply sort extension method. It should be an extension method on iQueryable that accepts the order by string from our query string, and a mapping dictionary containing all the maps between inputted values referring to the DTO fields to the actual entity properties. So it's quite a bit of work, but it will help us in the long run. Let me get rid of this for now, and let's think about that mapping dictionary first. So, you're watching a deep dive course, which means that you expect code you don't write every day, right? Well, I think this may be one of those occasions. We can have sorting on multiple field names of the resource, but one resource property might map to multiple properties on the entity. For example, the name property of the author DTO is a concatenation of first name and last name on the entity. Moreover, we're going to allow sorting ascending and descending. And in case of the age, that might be an issue. The higher your age, the lower your date of birth. So in that case, the passed-in sort order should be reversed. We could just create a hard-coded list. But let's make this reusable. We're going to create a generic property mapping service and register it with ASP.NET Core's built-in container. Now, how can we do that? We will need a property mapping service class. It implements an interface, iPropertyMappingService, that allows us to register it on the container on interface instead of directly on implementation. This service holds a list of property mappings, like one that maps the properties we can sort on of an author DTO to fields on the underlying author entity in the data store. One such property mapping from a source to destination then holds all the mappings for example, the author DTO fields to the author entity fields. That's a dictionary. A simple one could be ID maps to ID. But as we know, that's not sufficient. One field on the resource might map to multiple fields on the entity, like name to first name and last name. So, the dictionary should have the field name of the resource as key, but another object as value, a property mapping value. That property mapping value should then contain a list of destination properties. With that, we can map the name field to first name and last name. And we will need something else. As mentioned, in case of age, the sort order should be reversed, as when we sort ascending by age, that actually means we sort descending by date of birth. So, our property mapping value should also have a revert property. With that, we have all the information we need for our mappings. On our property mapping service, we should then have a method to get a specific mapping. Get property mapping from source to destination, for example, from author DTO to the author entity. It's a bit of work, but in the long run, this really helps towards reusability. Let's dive in.